All right, we're going to get started here with questions 7, 8, and 9. Yeah, okay, so let's do that. Questions. I was going to take a drink of coffee, but all right, we'll get you started. An inspector inspects large truckloads of potatoes to determine the proportion P in the shipment with major defects prior to using the potatoes to make potato chips. Potato chips. Unless there's clear evidence that this proportion is less than 0.10, she will reject the shipment. To reach a decision, she will test the hypotheses P equals 0.10 versus the alternative P is less than 0.10, using a large sample test for the population proportion. To do so, she's going to select an SRS of 50 potatoes from the over 2,000 potatoes on the truck. Suppose that only 2 of the potatoes sampled have found to have major defects. What conditions for inference about a proportion are violated? Okay, so maybe we should take down the important stuff here. So first of all, we already have P listed over there. It's 0.10. And what else do we see there? Oh, we see SRS of 50 potatoes. That's N, the sample size. Okay. And what else do I see? Oh, over 2,000. That is the population size. Remember, we use capital N for the population size, and we're saying the population size is greater than 2,000. How much greater? Is there anything that we can get out of here? Oh, you know what? We have only 2 potatoes that have major defects. So from that, we can get P hat. P hat is going to be 2 out of those 50 potatoes, which would be, what, 4%? 0.04. All right, that's our fat. Cool. Conditions for a hypothesis test. Any hypothesis test we do, there are these 3 conditions. The first one is randomness. So let's see, did we satisfy the random condition? Yeah, we did. We were told that this is a SRS is a simple random sample. Okay, so we didn't fail condition 1, or we didn't violate condition 1. 10% condition. Ooh, did we violate the 10% condition? Let's see. For 10%, 10 times n would be sample size. That would be 10 times 50, which is 500, which is less than 2,000, the minimum possible population size here. So no, we didn't really we didn't violate the SRS, the 10% condition. So the only thing we could have violated is normality. So what is the normal condition? The normal condition for tests about proportion is the large sample test. So large samples. Okay, so large sample says that n times p needs to be greater than or equal to 10. Let's check. What is n? Well, that's 50. What is p? Well, that's from the why did I type it wrong here? That is from the null hypothesis up here. P is 0.10. Let's see, what did we get? 5. That's a fail because it's less than 10. Fail. There's also a second part of the large sample test, which is, if we were not gonna, if we weren't doing this scholastically, we wouldn't necessarily need the test. But, for the sake of science, school, we're going to go ahead and test that. That's n times 1 minus p. that should be greater than or equal to 10 also. So let's check. N, still 50. 1 minus p is 0.9. Put a multiply sign there, and we get 45. Yeah, so this is not a fail. But we did fail large sample because they both need to be true. Both of those need to be greater than or equal to 10, both NP and N1 minus P. So we have failed normality. Sample fails the normality condition, which is the large sample condition. Let's spell correctly. So no, we can't use the hypothesis test here. Sorry. We would need a bigger sample, bigger than 50 potatoes. All right, let's take a look at what's next. A random sample of 900 individuals has been selected from a large population. How large? It was found that 180 are regular users of vitamins. Thus, the proportion of regular users of vitamins in the population is estimated to be 0.20. Does that math check out? 180 over 90 is 18 over 90, which is, I don't know, 0.2. Standard error is approximately. Okay, I did some work ahead of time, and I copy and pasted the formula for standard error. You need to have that memorized for my test, for most tests. So let's get on that. Standard error is of this estimate is p 1 minus p over n square root of. So square root, we're going to just put in our numbers here. What are the numbers? P is 0.8, no, 0.2. And 1 minus p is 0.8. N is 900. Okay, so moment of truth, what is that number? I don't know, I'm not a calculator, or at least I'm not that good of a calculator. Let's turn to the TI. TI says square root fraction bar. Okay, that is 0.2 times 0.8 over 50. 50? What is the sample size again? I forgot. Oh, 900. Ah, 0.133. Just for curiosity's sake. Don't worry, this isn't part of the test or anything. They told me that 180 out of 900 is 0.2, and my mental math was not sufficient for that at this time, but it is 0.2. Okay, good. So 0.133, 0.0133. That's my standard error. Error. Okay. Number 9. There we go. Okay, null hypothesis is actually false is rejected. What kind of error did we make? I literally searched on Google Images for this. So these kinds of things are all over the place. So we rejected, or we have a null hypothesis that's not rejected. So we think that the null hypothesis is true. So we think the null hypothesis is true. That puts us on the top line, but hold on, that is actually false. Oh, I'm sorry. The null hypothesis is actually false. Ooh, no, not that. If the null hypothesis is actually false, the reality here is false. Okay? Is not rejected. So if it's not rejected, ugh, I don't like this one at all now that I look at it. So the null hypothesis that is actually false is not rejected. So we think that it's true. That says that we made a type 1 error, false positive. Type 1 error. Well, that was horrible. This chart is horrible. I'm gonna pull it off, take this off because it just looks bad. I actually don't understand what it's trying to say because reasons, but the important one for you. So here's what I'm gonna do. I'm gonna kill this chart here. I don't like that, but I am gonna go to this chart and I'm gonna say, hey, the null hypothesis is actually false, and we failed to reject it. Yeah, that means that we made a type 2 error. Look at that, type 2 error. So that's what we should have, that's the actual answer. I don't know what the hell that other part was saying. So this is a type 2 error. You know they mean business because whenever you see type 2 error, it's done with Roman numerals. So yeah, new Roman numerals means we mean business. Okay, this is a type 2 error. And I also included this little chart for you. That's kind of a fun one. Type 2 error is when, yeah, we fail to reject the null hypothesis, but the null hypothesis is actually false. So there you go. This is a type 2 error, and ugh, that was horrible. Okay, that's it for us, folks. Right. Catch you later.